Greetings everyone! Today we're going to explore factoring using the AC method and difference of squares. You'll want your foldable to take these notes in for this entire unit. On your foldable, turn to the tab that says Trinomial Factoring AC Method 3 Terms. Let's walk through the AC method. There are 3 key points and steps that we're going to explore. The first step is to take A coefficient times C the constant. Let's look at an example. When we talk about standard form, that means that the exponents are descending order and the constant is on the end. Your A coefficient is going to be the number in front of the variable with the highest exponent. The C is typically on the right in standard form because it is your constant, meaning it does not have an x value with it. So we're going to take the A and the C value and we're going to multiply them by each other. Then we want to take a moment to ask what multiplies to make that number but adds up to the middle term. Our middle term is the B value. Now this X template that I'm using is just a way to organize information. It makes it a little bit easier to understand what we're multiplying together and what we need to add together. Then we can separate this into a 4-term grouping problem. So these first 2 steps are what's new. From there, we'll continue using grouping from our previous lesson. Let's apply this to some examples. One of the key things we should always do is identify our A, B, and C value. On our first example, we don't have a number listed in front of the x squared, which means there is a 1. Therefore, my A value is 1. My B value is 7, and my constant or my C value is 6. If we use this template of A times C over B, let's fill that out. A times C would be 1 times 6, and my B value is 7. Now we have to use some deductive reasoning to determine what 2 numbers multiply to get 6, but add to get 4. So we are looking for the factors of 6 that can add to get me 7. So one of the suggestions is to list all the factors of 6, 1 times 6 and 2 times 3. Which one of those can add up to get 7, 1, and 6? Therefore, we are now going to take the middle term and separate that into my 2 new middle terms that I found. Instead of 7x, I now have a 1x and a 6x. So you can see all I did was break apart that 7 into 1 and 6. Those are the new steps. Now we're just going to use our grouping process from our previous lesson. Group the first 2 terms, group the last 2 terms. Take out a GCF out of your first set. In this case, the number would be 1, and I can take out an x out of both. Remember, anything divided by itself is 1. It doesn't go away. There is a value there. In the second parenthesis, I can divide a 6 out of both terms, and it would be a positive 6. Anything divided by itself is 1. Remember, the goal of grouping is to have the same factor twice. If I divide out that factor of x plus 1, I have remaining x plus 6. To overview, remember that factoring is just the reverse of multiplying. If I was to FOIL or use the box method for these 2 factors, I would end up back at the original question. Let's take a look at another example. First, identify your A, B, and C. Our A value is 1 because there's always a 1 in front of a variable if you don't see a number. Our B value is negative 6. Make sure that you carry those signs down with the number. Our C is negative 16. Create your template. On top, we want A times C On bottom, we want b. So in this particular example, a times c would give me negative 16, and carry down your b value, which is negative 6. I now need two factors of 16 that can add to give me negative 6. What signs you use will play an important role on this example. Let's take a look at the factors of 16. 1 and 16, 2 and 8, 4 and 4. Out of those combinations, which one can get you to a 6? Not 1 and 16, not 4 and 4, so my only option is 8 and 2. Now we need to look at our signs. One of them has to be negative, because a negative times a positive would get me to my negative. We also need them to add to get a negative 6. Therefore, the only option that works is to have a negative 8. Let's double check our work. 2 times negative 8 gives me negative 16. 2 plus negative 8 gives me negative 6. So I know I'm right before I even continue the problem. These created our two new middle terms. So let's write it out as 4 terms. Keep the first term, keep the last term. But now instead of negative 6, we've broken it up into positive 2 and negative 8. Carry those x's. Your middle term always has an x value. Now we're referring back to the previous lesson of grouping. Group the first two, group the last two. I can divide an x out. Therefore, my GCF is x. I have remaining 1x plus 2. In my second set of parentheses, I can divide out not only an 8, but a negative 8. Carry those negatives out with your GCF. That leaves me with an x and a positive 2. Negative divided by a negative is positive. I ended up with what I needed, the same thing twice. Therefore, if I divide out my common factor of x plus 2, I have remaining the factor of x minus 8. If you're unsure if that's correct, you can always FOIL, and you should end up back at the original question. Let's take a look at a third example. This third example is unique because I actually have an a value that is greater than 1. This time my a value is 3, my b value is 1, and my c value is negative 2. Let's set up our template. A times c goes on top, therefore negative 6. Your b value goes in the bottom. I need to think of two factors that multiply to get negative 6, but add to get 1. Let's refer to our factors of 6 first. 1 and 6, 2 and 3. Out of those factors, which ones have a difference of 1? That leaves me with the option of 2 times 3. But now we need to pay attention to our signs. If they multiply to get a negative 6, that means one value is negative. If you need to do some guess and check here, you can. You could try negative 2 first and check your work. Negative 2 times 3 is negative 6. Negative 2 plus 3 is positive 1. So I guessed right on the first try. It's a negative 2. Let's take our middle term of 1x and separate it into two new middle terms. I now have the middle terms of negative 2x and positive 3x. And bring down your constant of minus 2. Refer back to your previous lesson of grouping. Group the first two, group the last two. I have a common factor of x. When I divide an x out, I'm left with 3x minus 2. Take a look at that right set of parentheses. What divides into 3 and 2? You can always divide out a 1. And in this case in grouping, you always have to divide something out. So if you don't think there is anything, you can always still take a 1 out. It's going to be a positive one in this particular case because they're both not negative. If I divide a 1 out, I'm left with what I originally had. I know I'm right because I ended up with the same factor twice. Let's divide out that common factor of 3x minus 2. When I do that, I have an x plus 1 remaining. As previously stated, if you're unsure if that looks correct, multiply it using FOIL or the box method, and you'll know you're right because you end up back at the original question. Let's take a look at difference of perfect squares. This is a unique situation where you can still use the AC method, but it ends up taking a little bit longer. It would be much quicker if we remember the rule for difference of perfect squares. For the first bullet, let's write down identify if you have each of the following. Next to number 1, you need a difference. Next to number 2, you need a perfect square. Well, what does that mean? A difference means you have to have one factor that's positive and one factor that's negative. You need to have one difference. A perfect square implies that you can take the square root and you will get a whole number or a whole value. For example, x squared is a perfect square. 9 is a perfect square. 25 is a perfect square, and so on. For the second bullet, we then use it to factor it into two factors, one positive and one negative. Let's apply this to some examples so it makes more sense. Taking a look at example 1, you first want to decide, do you have a difference? Meaning, do you have a subtraction sign between two terms? In this case, I do. X squared is a perfect square, and 49 is a perfect square. So the rule states that you can set up your two factors. Your square root of x squared is x. Square root of 49 is 7. We end up with a positive and a negative value. Let's take a look at why that works. If I was to FOIL this back out, first terms, outer terms, inner terms, last terms. Notice what happens. I have a negative and a positive value that cancel out. And I'm back at the question of x squared minus 49. Let's take a look at another example. Again, we have a difference, so I know I can use this special rule. If I take the square root of both terms, the square root of 4 is 2. The square root of x squared is x. The square root of 9 is 3. Then, because it's difference of squares, we have different signs, a plus and a minus. Notice the order on example 3. Even though it's not in standard form, we can still use difference of squares. Set up your two parentheses. We have a difference. We can square root both sides. Square root of 81 is 9. Square root of w squared is w. Opposite signs, plus and minus. Let's take a look at example 4. Set up your two parentheses. Determine if you can square root both sides and that you have a difference. The square root of 16 is 4. Square root of x squared is x. Square root of 25 is 5. And since it is difference, you have one plus and one minus. Let's look at example 5. Before I even get started, let's acknowledge that I can square root 4 and x squared, but I cannot square root 7. That is not a perfect square. Therefore, I cannot use perfect squares to factor this polynomial. Sometimes we need to remember to use GCF first. So for example, when I look at example 6, I cannot just square root 5 and square root 20. They are not perfect squares. But I can take out a GCF of 5. If I divide 5 out, I have x squared minus 4 remaining. Now, x squared is a perfect square, 4 is a perfect square, and I have a difference. Let's set up our two parentheses. Square root of x squared is x. Square root of 4 is 2. Because it's difference, we can do adding and subtracting. Remember to bring that GCF down. We can't just eliminate it. It's part of the original question, so we carry it down to our answer. On example 7, take a moment to figure out what our GCF would be. The first thing I notice is I can divide both sides by 2. Can I divide anything else out? In this case, because they both have at least one x, I can divide an x out. My GCF is 2x. 2 divided by 2 is 1. X cubed divided by x to the first leaves me with an x squared. Bring down your sign. 72 divided by 2 is 36. X divided by x is 1, so we don't need to carry that down. Now I have difference of squares. X squared is a perfect square, 36 is a perfect square, and we have a minus sign. Let's set up our two parentheses. The square root of x squared is x. Square root of 36 is 6. Opposite signs. And don't forget to carry that GCF down all the way to your answer. So again, the key thing we're looking for here is, can I take the square root? And do I have a subtraction sign in between the two terms? If either one of those is missing, we cannot use difference of squares, and we can see if there's possibly another way to factor. Quick recap of what we've added to our notes foldable. Two methods of factoring. The first method we are going to use over the next few units, and that is the AC method. A times C up top, B on bottom. Determine your two factors and set up your 4-term polynomial so that you can use grouping. The second method was difference of squares. Difference of squares, again, is only an option if you have two terms with a subtraction sign and they are both perfect squares. If you have any questions or need any additional help, make sure you visit with me, and we'll see you next time.